Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have our National Senior Certificate, grade 12. And then this is Mathematics, paper 1, November 2024. Paper that was just written last year around this time. So we're just going to be using it to practice for our upcoming November 2025 Mathematics paper 1, which will be written around the first week of November. So we have our max, it's 150, and then the time is 3 hours. So hopefully we'll be able to finish off this paper within less than 3 hours. So just going through the question paper and showing you how to actually go about it. Okay, so let's start. We have our question 1, which is our algebra, as we know. And then obviously, when it comes to this question, you should be aiming for at least 90%, right? 90% of whatever that you've been given there. So if ever you're going to get anything wrong here, can be 1.3. But then out of this 27, you are hoping to get something like 24 because all these questions, I believe you've been doing them repeatedly and now you can see that they never change, right? So we have our 1.1.1 here, which is this. So it's the most basic solve for x already in standard form. So we know if we have a question like that, all we have to do is just say x is equals to 0 or x is equals to 3. And then they're just going to mark 1 for this and 1 for that. So that's your 2 marks there. Now for 1.1.2, we have 2x squared plus 1 is equals to 4x. And then we have a statement that says correct to 2 decimal places. Now you always have to understand that whenever you have that statement, it simply means that you have to apply your quadratic formula. But before you can apply quadratic formula to this one, you need to first rearrange it into standard form, right? So it needs to be in the form of ax squared plus bx plus c, so that you can be able to visibly see your value of a, b, and c, right? So what we are going to do is first write it in standard form. So by taking the 4x and then we have negative 4x and then plus 1 equal to 0. So this is now in standard form, meaning our a value is the coefficient of x squared, and then our b value is the coefficient of x, and then our c value is the constant 1, right? Then now we can write out the formula for the quadratic formula. If you ever forget these formulas, guys, do not be ashamed to go to your data sheet. The last page of the question paper is your data sheet where you have all these formulas, right? So you can just check them there instead of having to write the incorrect formula. So negative 4 squared minus 4, our a is 2 and then our c is 1, all over 2 multiplied by 2. Then obviously at this point, you're just going to grab your calculator, aka umshini ibalo, and just punch all of this. So you have your x is equals to 1.71, or your x will be equals to 0.29. Now, obviously, you know you have to first start by a positive here and then followed by negative. So at the end of the day, you must have 2 different answers, right? So, okay, that's it. So just like that, you have bagged yourself 4 marks, right? Now, if you are curious about where you will actually get the marks, there is a mark for the standard form. There is the mark for the correct substitution here into the quadratic formula, and there is a mark for each of the answers, right? So that's your 4 marks there. Now, obviously here you had 1 and 1. Okay, so that's it. So 1.1.3, we have x squared minus 2x minus 3 is greater than 0. So what are we supposed to do there? Already we can see that this is in standard form. Now you will remember that I did mention that when you see your inequality sign from the question is facing that side, then you always have to remember that your answers normally end up like this, right? This is where you will have your x is less than the minimum value, or your x is greater than the maximum value. So that's if your inequality sign is like this from the standard form. Now from the standard form equation, if your inequality sign is facing the right-hand side like that, it's a greater than sign, then you normally have your solutions like this. But then if it's facing that other direction from your standard form equation, then normally what I did say is that your solutions will be the one whereby you have a combination here where you say x is greater than the minimum value, but x will be less than the maximum value, right? So this is normally where you have something like this, where the answers will be outside of the critical values. And then this is where you have your solutions being inside of the critical values, right? So always note that. So you just look at your sign from the standard equation. So you have to look at it when you have already made sure that it's in standard form, right? Okay, so what are we going to do in order to answer that? So for 1.1.3, we are going to say this is x squared minus 2x minus 3 greater than 0. So we can all agree that it's easier to factorize this because the only factors of 3 are 1 and 3. So we'll have x minus 3 and then x plus 1 greater than 0, right? Now, obviously here, your critical values now will be what? X will be equals to 3, or your x will be equals to what? To negative 1. But then obviously, because we are dealing with inequalities, you should not leave your answers to the critical values. This is the point now where you should write it in correct format. So in correct format, you have to say your x is less than the minimum value, which is negative 1, or x is greater than the maximum value, which is 3. And then that's how you have your solution. Or you can represent it in that fashion to say this is your negative 1 and this is your 3, and then you just shade off these parts here to show that your equation or your inequality will only satisfy for values that are outside of the critical values. Then okay, just like that, you beg yourself 4 marks. Where are we going to get the marks? We're going to get the marks for the factors. So the factors will give us a mark, and then the critical values will give us a mark, and then also the answers will give us a mark, each of the answers. Okay, so now we move to 1.1.4. So this is your exponential laws. So we have your 2 to the exponent of 2x, so 1.1.4. And then minus 2 to the exponent of x plus 2, and then minus 32 is equals to 0. Now we can choose to shire it clean, or we can use the K method. Let's start with the first option where you just tackle it clean like that. So this is 2 to the exponent of 2x, and then this one will break down to 2 to the exponent of x, and then 2 to the exponent of 2, right? And then minus 32 is equals to 0. Now 2 to the exponent of 2, we know that this will have to give us what? 4. So I'll just write 4 here in front, and then 2 to the exponent of x. So I didn't change anything, only the format. I just started with the coefficient here, then followed by that. Now at this point, I can just factorize this. Remember, I know that 2 to the exponent of 2x is the same as having 2 to the exponent of x and another 2 to the exponent of x. So I can just factorize this by saying each bracket will have 2 to the exponent of x. Now, I want the factors of 32. These factors of 32, when you multiply them, they must give you 32. But then when you subtract them, they must give you 4. What are those factors? We can say the factors are 8 and 4, right? 8 multiplied by 4 will give us 32. But then 8 minus 4 will give us 4. So perfect. Now, it's just a matter of looking at your signs here, and then you will determine that the bigger value here would have to have a negative sign, and then the other value would have to have a positive sign. So this is 2 to the exponent of x, and then plus 4 is equals to 0. So negative 8 multiplied by 4, that's negative 32. Negative 8 plus 4, that's negative 4, right? So look at this, right? Okay. So now at this point, we can see that this is already in standard form. So we can equate each and every bracket to what? To 0. So this is 2 to the exponent of x minus 8 is equals to 0, or 2 to the exponent of x plus 4 equal to 0. Now this is 2 to the exponent of x is equals to 8, or 2 to the exponent of x is equals to negative 4. But then this one, immediately we're just going to say it's not applicable because there is no exponent value that you can put here that will result in a negative value, right? So there is no such thing as a negative value from an exponent. So this is not applicable. But then the 8 here, we can write it in what? In exponential form. So 8 can be written as 2 to the exponent of 3. Why are we doing that? It's because we want to take advantage of the law that says in an equation, when the bases are the same, we can just drop off the bases and equate the exponents. So the bases are 2 and 2. We drop them off and then we just equate the what? The exponents. So that is x is equals to 3. So we only have one solution there. Our x is equals to 3. There is no solution for this one because it's negative, and then there is no exponent that produces a negative value. Now, this is one way in which you could have done that for 5 marks, right? Okay, now suppose that you do not understand this part whereby we were able to break down the 2 to the exponent of 2x to that and that. You can still use the K method, whereby now you're saying, okay, this kind of looks complicated to me. Let's say this is 2 to the exponent of 2x minus 2 to the exponent of x, and then 2 to the exponent of 2, and then minus 32 is equals to 0. Now, we do know that 2 to the exponent of 2x, according to our exponential laws, is 2 to the exponent of x and 2 to the exponent of x. So in this case, we're going to say let 2 to the exponent of x be expressed as k. So instead of solving for x here, I'll start by solving for k. Now, if I'm saying that 2 to the exponent of 2x is 2 to the exponent of x multiplied by 2 to the exponent of x, what I'm simply saying is that this is k multiplied by k, which means all of this will be what? K squared. And then 2 to the exponent of 4 to the exponent of 2 is 4. Remember, the 2 to the exponent of x can be replaced as k, then minus 32. So I am still going to factorize this the way I did, minus 8, then k plus 4 is equals to 0. Now my k is either equal to 8 or my k is equal to negative 4. But now I have to remind myself that, remember, k was not what I was initially calculating. K was just only a scapegoat for now, right? What I'm trying to calculate is what? X. I'm trying to solve for x. So I have to say, but k is equals to 2 to the exponent of x. What does this mean? It means where there is k, now I have to replace back by that 2 to the exponent of x. And then this is equals to 8. Also, again here, 2 to the exponent of x, which is equals to negative 4. Now, at this point, we can see again that this will be not applicable. And then we still continue with that one. This is 2 to the exponent of 3. And then x is equals to 3. Bases are the same, so we equate the exponents. So either way, you still end up to the same answer there. So pick your poison, pick which one actually makes you to understand all this concept. Okay, sharp. Then 1.1.5, we have this. So 1.1.5, this is square root of negative 2x plus 4. And then this is outside, right? So we have minus x is equals to 2. So the first thing that we are going to do here, we know with this kind of questions, we should always isolate the root, right? So we don't want anything in front or after the root, right? We just want an equal sign. So the first thing that we are going to do is take this over to that side. So we want to have square root of negative 2x plus 4 is equals to x plus 2. So this negative x will become positive x. Now at this point, we can see that our challenge is that we have the square root here. So we can't solve anything with the square root, with the expression still inside the square root. So how do we get rid of the square root? We square both sides. Remember the rule of maths, what you do on the left-hand side, you also have to do on the right-hand side. But then the purpose of the square here will just be to get rid of the square root. And then we'll be left with the negative 2x plus 4. Now here, because there's no square root, it means that expression would have to expand twice, right? So we have negative 2x plus 4. And then this will give us x squared. X plus 2x will be 2x. And then this is 2x. So all in all, we'll have 4x. 2 multiplied by 2, that's 4. Right? And then let's do our maths now. If we take this all over to that side, we have x squared plus 4x plus 2x and then plus 4 minus 4. And then, okay, so there's the 0 there. Okay, then we're going to have 0 is equals to x squared, 4x plus 2x, that's 6x, 4 minus 4, that's 0, right? So let's rearrange it. We're going to have x squared plus 6x equal to 0. The common factor between the two terms is x. So factor out x, we're going to have x plus 6 here equal to 0. So again, it goes back to this, right? How did we solve this? We know that at this point, all we have to do is just say x is equals to 0 or x is equals to -6. And there we go. We have our two solutions. But it is always very important to note that with this kind of questions, you have to take your values and test them against the expression or the equation to see if they both satisfy the equation. It is much possible that only one of the values will satisfy the equation. Let's see. If I decide to put 0 here, I'm going to have -2 multiplied by 0 plus 4 and then minus 0, right? So obviously this will leave us with square root and then square root of 4 and then square root of 4 is 2. So the left-hand side is equals to the right-hand side in this case, because all we are trying to do is we are trying to find out if we're going to be replacing by x here, will we still be able to get that 2, right? So we can see with testing with 0 here, we do get that 2. But then let's see with testing by -6. So if I put -6 where there's x, so that's -2 and then -6 here plus 4 and then minus -6. Let's see. So 2 multiplied by -6, that's 12. 12 plus 14, that's 16, right? Square root of 16. And then this is negative and negative will give me +6. Now square root of 16 is going to give me what? 4, right? And then 4 plus 6, unfortunately, gives me 10, which is not equal to this. So the left-hand side is not equal to the right-hand side whenever we are using what? -6. So what must we do now? We must come here and cancel off that value there. So it's a mark to come there and cancel off a value, right? So where are you going to get the mark? Isolating the root, number 1. So if you isolate the root, that's a mark. Squaring both sides, right? It's a mark. So squaring both sides, it's a mark. So that means we were supposed to show that step and then square afterwards. Okay, then we squared both sides and then standard form. Where do we have our standard form? Right here. And then they're going to give us a mark only if we have cancelled out that value. So for someone who just wrote x is equals to 6 and x is equals to -6 without having to cancel off this one, they won't get a mark. So it's only 3 marks. So, but then if they see that you cancelled off that x is equals to -6, then that's when you're going to get the 4th mark. Okay, so nice. So you are noting all those. You are noting all those things that you need to be careful of. Then 1.2 says solve for x and y simultaneously. Okay, so 1.2. Now we know the rule with simultaneous equation is that if you are given 2 equations like that, you always have to look for the simplest equation. The simplest equation will most definitely be the one that is linear in most of the cases. So we can see that this has a square there, a degree. So that means we won't be taking it as the simplest equation. But when we look at equation number 1, this is a linear equation, right? So we can take this one and say we're going to work with equation 1. But then working with equation 1, again, we have to choose which variable do we make the standard, the subject of the formula meant to say. Now, always choose to make the subject of the formula the variable that is the lowest coefficient. Understand that. Make the subject of the formula the variable that is the lowest coefficient. Now, if you can check, x has a coefficient of 2. Y only has a coefficient of 1, meaning that we wouldn't be complicating this if we make y the subject of the formula, because there will be no need to divide anything out or create a fraction. So we're going to be working from equation 1. So this is y is equals to 3 minus 2x, right? So I will say this is equation what? 3. Now, it doesn't matter if you say negative 2x plus 3, still the same thing. Now you have equation 3. Remember that equation 3 and equation 1, that's just the same thing. So that means you have to take this equation 3 and substitute it into what? The equation that you haven't used yet. So substitute equation 3 into equation 2. This is always the process for your simultaneous. It never changes. So what does it mean? Where I see y, I would have to replace by this expression. So I will have y squared here. This means I will have to have 3 minus 2x squared plus x. And then where there is y again, I have to put the 3 minus 2x and then equal to 2. Now, obviously, the square here means that I have to expand this. 3 minus 2x. Now, here I can just multiply inside by this x. I will have plus 3x minus 2x squared. Then let me just transpose the 2 over to the side. Minus 2 equal to 0. Now, dealing with this, 3 multiplied by 3, that's 9. 3 multiplied by that, that's negative 6. Also here, we'll have negative 6. And then here and there, I will have positive 4x squared. And then plus 3x minus 2x squared minus 2 equal to 0. Now, let's look for like terms. Like terms, 4x squared minus 2x squared. And then other ones, we have negative 6x, negative 6x, positive 3x. And then we also have constants, right? So our constant is 9 and negative 2. So let's deal with those. So obviously, following the order of degrees, we'll have 4x squared minus 2x squared, that's 2x squared. Negative 6 minus negative 6, that's negative 12, plus 3x, that's going to be negative 9x. Is it? Okay. Let's see. Okay, negative 12, and then plus that, okay. Then we have 9 minus what? Minus 2. So 9 minus 2 will give us what? 7. So I was still confirming that everything is correct. Yes, we are still moving in the right path. So, okay, at this point, you obviously need to factorize this. Now, it's not a train smash. If you can't factorize that, you can still put it in your quadratic formula. Remember, I've been teaching you the trick to make it seem as if you factorized while you use the quadratic formula. So from the answers that you'll get in your quadratic formula, you'll have x is equals to 7 over 2 or x is equals to 1. So you want to make it seem as if you factorized. This is what you're going to do. You're going to take the 2, cross multiply it here. It's going to be 2x, and you're going to take the 7 and transpose it over to this side as minus 7. So that means your factor here is 2x minus 7, right? Then what are you going to do with this one? You're just going to take the 1 and transpose it over. So that's x minus 1. So these are your two factors that you have there. So 2x minus 7 and then x minus 1. Now, who will tell that you used the quadratic formula? No one. So this is 7 over 2 or x is equals to 1. Those are the values. But then remember, this is simultaneous, right? Simultaneous means that we solve for x and y, right? So that means since we have our x values, now it's time for us to find our y values. But how do we find the y values? You have to go back to the standard form equation, which is equation number 3, right? And then now you're going to say, for when x is equals to 7 over 2, you're going to have y is equals to 3 minus 2, and then 7 over 2. So which will give us what? So this and this will obviously cancel. 3 minus 7 will give us what? Negative 4. Right? And then we have another one. For when x is equals to 1, then that means I will have y is equals to 3 minus 2 multiplied by 1. And then 2 minus 3 minus 2 is just equal to 1. So there you go. You have your solutions for x and y simultaneously. Right. And then where do we get our marks with this one? So creating that equation there, in my case, it's equation 3, right? And then a standard form, where we have all of this in standard form, it's a mark. So before that, the substitution, and then standard form, and then both the x values get 1 mark. So if both your x values are correct, 1 mark. And then both y values are correct, 1 mark. So 1, 2, 3, 4, 5 marks, right? So nice. We have that 5 marks in the bag, just like that. Okay, then coming to the main question, 1.3. Biskala. Yeah. Consider the product bracket 1 plus 1 over 2, bracket 1 plus 1 over 3, bracket 1 plus 1 over 4. Each factor in the product is of the form y, bracket 1 plus 1 over n, for n is greater or equal to 2. Determine all the values of n for which the product will be an integer value. We want where the product will be an integer value. Now, looking at this, we are being told that our n values must start from 2 going upward, right? So as we can see here, the n value being the value in here represents that it's starting at 2 and then it's increasing gradually like that to the next integer, like that. But then we want where the product, let's look at this. The product is a what? The product is a result of multiplication. This is a result of multiplication, right? So we want where when we multiply in the brackets, we will have an integer value. So, okay, what we can do with this is simply add this, right? So if we can say 1 plus 1 over 2, we get what? 3 over 2, because that's more like the 1. We're going to write it as 2 over 2. 2 plus 1 is 3, and then 3 over 2 like that. So just like that, we're going to have 3 over 2. So look at the pattern. And then here we're going to have what? 4 over 3 followed by 4 over 3. So if it was just a matter of multiplying this 2 here, then it was just simply this. So this is that, and this is that. Cancel that, and then this will give us 4 over 2 is equals to 2, which is an integer value, right? But then this happens when our n here is equals to what? This happens when our n value here is equals to 3. So this is 4, n is equals to 3. Now let's continue and go for the one where n is equals to 4. So that means we have to continue and say 3 over 2, 4 over 3. Note that I'm adding these ones for 4 over 3. And then when I add these ones, I'm going to get what? 5 over 4. Now, if I have to deal with this one, this will cancel, that will cancel, that will cancel, this will cancel. I will have what? 5 over 3. 5 over 2 meant to say, which is not an integer. Not an integer. So that means we won't be considering when n is equals to 4. Let's skip now and say we continue to when n is equals to 5. So 3 over 2, 4 over 3, 5 over 4, and then 4 over 5. So this is the 5 now. So what happens? This cancels, that cancels. This cancels, that cancels. This cancels, that cancels. Then we are left with what? 4 over 2 again, right? Which is going to give us what? Oh, not that. Where do I get the 4? 6 here, sorry. So this is 6. Yes. So cancel that. Sorry for that. So this is 6 over 2. And then the 6 over 2 here will give us what? 3, right? So, okay, let's continue with that pattern and see if it holds. Then if our n is now equal to 6, that means I'm going to have 3 over 2, 4 over 3, 5 over 4, and then 6 over 5, followed by what? We will have 7 over 6, right? So what happens here is that this cancels, that cancels, this cancels, that cancels, cancel, 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 cancel. Then we are left with 7 over 2, which 7 over 2 will not be an integer. So we won't be considering when n is equals to 6. Now let's consider when n will be equals to 7. So at this point, I think you actually pick the trend. So 4 over 3, and then 5 over 4, and then we have 6 over 5. We have 7 over 6, and then we have 8 over 7. So what happens? Cancel, 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 cancel. Then we are left with 8 over 2. 8 over 2 will give us what? 4. So basically what we are seeing here is that every time our n is an odd number, so when our n is 3, our n is 5, our n is 7, again it will happen when our n is 9, our n is 11. So every time our n value is an odd number, that's when we have an integer value for the product, right? That's where we have an integer value when we multiply that product. So in this case, that means we are supposed to say what? Therefore, n must be odd. Must be an odd number. Greater than what? Greater than 2. So it must be an odd number that is greater than 2, because all the odd numbers starting from, remember, we are not supposed to use 1, right? So it's starting from 2 going upwards. So it must be an odd number that is greater than this 2, meaning your 3, your 5, 9, 11, 13, all the odd numbers will satisfy that, right? So that's when your n is an element of all the odd numbers, 3, 5, 7, 9, all those numbers that are odd numbers. So that's basically how you were supposed to calculate that question. So it's one of the high order questions. They do not necessarily need you to apply a lot of calculations, just a matter of understanding your maths. So they just testing your knowledge of the relationship of numbers, right? So those are one of the high order questions. These are the questions that maybe you can allow yourself to lose, right? But then all the other questions, they are within the norm, and then you should always be able to get them, right? Okay. All right. So now we have question 2 on our arithmetic and quadratic formula. So the first term of an arithmetic series, they say, is 7. The common difference of this series is 5, and the series contains 20 terms. Now 2.1.1 is saying calculate the sum of this series. So to calculate that, we are going to just say Sn is equals to n over 2, and then 2a plus bracket n minus 1, and then we have d like that. So how many terms do we have? That's 20 over 2, and then our first term, they said, is what? 7, and then here we have 20 once more, and then multiply that by 5, close bracket. Then you're just going to punch all of that into your calculator. You get that the sum of 20 terms will give us what? 1090, right? So that's it. You're just going to get a mark for the substitution and the correct answer. Okay, then we have 2.1.2, which says the original arithmetic series is extended to 75 terms. What are they saying? It means from the 20 terms, they're now adding a certain number of terms to make it 75 terms. So if you can quickly do the maths, 75 minus 20, that means they added 55 more terms, right? They added 55 more terms. Now, if they add those 55 more terms, now the sum of this whole 75 terms now make 14,400. They're now saying, using sigma notation, write down the equation for the sum of the terms added to the original series. So this is what we're going to do. We understand that in order to find the difference, we'll have to say sum of 75 minus the sum of what? The sum of 20 terms, right? And then what are we going to get there? The sum of 75, we've been given that it's 14,400, and then we calculated the sum of 20 terms is only 1,090. So the difference that is made by the 55 terms is 13,310. So how do we then write this in sigma notation? Remember, with sigma notation, you need the general term, right? You need your nth term. So this is Tn is equals to a plus n minus 1, and then d. Remember, we are still using this same arithmetic series. Our a value is 7, and then we have n minus 1. Our d value, they said the common difference is 5. So we're going to have 5 here. So this is going to be 5n minus 5 and then plus 7, which is going to give us 5n plus 2. So that's our Tn. Then when we write the sigma notation, we're going to write it like this. We're going to say if our n starts from 1, then it must run all the way through until the 75th term, right? So until 75. But then what is the general formula guiding that? It's 5n plus 2. And then we have to subtract that. Remember, we are writing this. Our n starting from 1, but then only ending at what? At 20. What is the general formula guiding that? It's 5n plus 2. And then this gives us what? 13,310. Right. So this is how we write it in sigma notation. But then still you can simplify it further to say that the difference here, the 13,310, will start from all the terms from T21 all the way to T75. Now, how do you express that? That means the subtraction here will now have to give you what? Where your n is starting from 21 all the way to term 75, which if you're going to do this, you will find that it's exactly 55 terms. Then this is going to give us what? 5n plus 2, and then this is equals to 13,310, right? So that's basically how you go about it. So if you want to confirm that it's that, your number of terms is upper value minus lower value plus 1, right? So let's see if it's going to give us the 55 terms. Your upper value, 75. Now it has to start from term 21. So minus 21 plus 1. Remember, it ended at term 20. So when it starts, when they add the 55 terms, they're adding from 21 all the way to 75. So the 75 minus 21 is 54, and then plus 1, that's 55 terms, right? So which confirms that this is correct, right? So that's basically how you were supposed to write that. That's basically how you were supposed to indicate all of that. So there was going to be a mark for the general formula because you need it. There was going to be a mark for subtracting this, and then there was going to be a mark for having to be able to write it in sigma notation, and then finally being able to express it like this, right? So, okay, now you have how many marks? There was 4 marks, yes. 2.2 says the sequence of the first differences of a quadratic pattern is 1, 3, 5. Note this, the sequence of the first differences, not the quadratic pattern itself, but then the first differences of the quadratic pattern is 1, 3, and 5. Now, if T99 of this quadratic pattern is 9,632, calculate the value of T92. Now, you will always realize that if I have this, if I have a quadratic pattern, and then let's say this is the value of the first difference is 1, 3, and then 5, right? And then obviously second difference will be what? Will be 2. Now, if I want to get T1, right, you will realize that it's just a matter of saying T2 minus this value here. So whenever I get this second term minus the value from the first difference in my quadratic pattern, then I get T1. Also, if you want to get, let's say T2, you'll have to say T3 minus the value in here. It will give you T2 all the way like that. So that's the knowledge we'll be using. So in other words here, what we'll be trying to find here is, let's find the pattern that is created by this, right? 1, 3, 5. Now from here, we can already see that our common difference, remember the first difference, the one important thing that you have to note about the quadratic pattern is that the first difference always gives birth to the arithmetic sequence. If you can look at this, the first difference of your quadratic pattern is actually an arithmetic sequence. And then the second difference that you are seeing here is actually what we refer to as what? As the common difference in an arithmetic sequence. So always note that when they bring about a quadratic pattern, it is usually to hide the arithmetic sequence, right? So this is 1, 3, and then 5. Now we know that this, we want to take it as the common difference. This now will become our what? Our value here, right? So this will be the first value. So that means we are going to have Tn is equals to a plus n minus 1 and then d. Our a value is 1, and then we have n minus 1, and then our d value is 2. So this is 2n minus 2 and then plus 1. Then our Tn will be equals to what? 2n minus 1, right? But then remember, what are we trying to find? We are trying to find T what? T98. So we are being told if T99 of this quadratic pattern is this, then calculate T98. So let's see, T98 will be equals to 2 multiplied by what? By 98 minus 1. Whoa. Minus 1, like that. 2 multiplied by 98 minus 1, this will give us 195, right? Remember, this is the T98 from the what? From the first difference. From the first difference. What we are trying to calculate is T98 from the what? From the quadratic pattern. So this is what we're going to do. And I say to get T99, the same way I've been saying, to get T99 now, I would have to say what? I would have to say to get T98, I would have to say T99 from the quadratic minus T98 from the what? From the arithmetic or from the first difference. Same way I've been saying, if I want to get T2 here, I would have to say what? T2 is equals to the T3 here, and then minus what? The T2. The T3 from the quadratic, and then the T2 from the arithmetic. So that I get T2 of what? The quadratic. T98 of the quadratic, T99 of the quadratic, minus T98 of the arithmetic. So this is going to be what? 9,632 minus 195. And then what do I get? 9,437. So that's my T98. Right. There we go. Okay, so let that sink in. So it's very important that you note that. Whenever we are looking for something that has to do with the quadratic T2, then it's T3 of that quadratic minus T2 of the same arithmetic. Okay, then we have this 5 marks here, 2.2.2. It says it is further given that the third term of the quadratic pattern is 32. Okay, so from that first difference, we have 1, and then we have 3, and then we have 5. Now we are given that this will be T1, T2, and then T3, right? So we are given that this one is 32. Now, using the fact that I've been telling you, if I want to find T2, I must say 32 minus 3. And then I get what? 29. Let's say I want to find the T1, I must say 29 minus 1. And then I get what? 28. So that's the quadratic pattern. And then obviously, if you want to continue with it, you can say 32 now plus 5 to go to the next one. All the way like that. If you say 32 plus 5, that's going to give us what? 37. And then obviously you can see that here, what will follow here is what? 1, 3, 5, and then 7, all the way like that. So still here, your second difference is 2. Now, what are we supposed to do? Determine the general term, Tn of the quadratic pattern. So now we want Tn of the quadratic pattern. How do we start with that? We know that this should always be equated to what? To 2a. And then this equated to 3a plus b. And then this be equated to a plus b plus c. And then we only use the values of the first branch. The values of the first branch. Let's go now. We have 2a is equals to 2. Divide by 2, divide by 2, our a value will be 1. And then 3a plus b is equals to 1. So where there's a, we're going to replace by that 1. And then 1 here. B is equals to 1 minus 3, which means our b will be equal to negative 2. Now for c, I have a plus b plus c is equals to 28. So that's 1 minus 2 plus c is equals to 28. So 1 minus 2, that gives me negative 1. So c will be 28 plus 1 now. So c is equals to what? 29. So that means my Tn in the form of an squared plus bn plus c will now have to be what? My a value is 1, so I'm just going to write n squared. My b value is negative 2, so that's negative 2n. And then my c value is 29. And then there we go, 5 marks. I now have the equation. So where do we get our marks? Second difference, being able to find that our a is 1, our b value is negative 2, our c value is 29, right? And then being able to come up with the equation, obviously. So that is it. 1, 2, 3, 4, 5. Okay, so you have 14 marks in the bag, just like that. Awesome. All right, so now we have question 3. It says a circle with radius 6 centimeter is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Now, what you will realize here is that every time they draw a smaller circle, it becomes half the diameter of the older circle. So this is the new first circle. And then this is now the one that is drawn internally. So if you can just check here, we can see that now the diameter here becomes half of the diameter of that. And then again, if we continue drawing, we can see that the diameter of now the third new circle, smaller circle, now becomes half of the diameter of the second circle. So what we can actually do here is, remember, if the diameter halves, that means the radius also halves. Then we are being told that the first circle, so first circle has a radius of 6 centimeter, meaning the second circle, according to that pattern, will have a radius of what? 6 divided by 2, which is 3 centimeter. Then the third circle, which is what we are looking for, will now have to have a radius of 3 divided by 2, which is 1.5 centimeter, right? And then that's how we would indicate our 3.1. Now 3.2 says calculate the sum of the areas. Note that, the sum of the areas. Now we know with the area of a circle is pi r square. So that means, considering the 6, 3, and 1.5, let's write down the areas of this. So the first one would have to be pi 6 squared, followed by what? Pi 3 squared, followed by what? Pi 1.5 square. Now this will give us 36 pi as the first term. This is 9 pi as the second term. And then here we will have what? So let's do 1.5 square. That's 2.25 pi, right? Okay, now at this point, this is what we're going to do now. This is the first term, so this is A. 36 pi. Now let's find our R. Our R, we can say T2 divided by T1. So we know that this forms a geometric pattern, we've been told. So 9 pi divided by 36 pi. Pi and pi will cancel out. So what is 9 divided by 36? This is supposed to give us 1 over 4, right? So that is our common ratio, our constant ratio. Then now to calculate the sum, we will say Sn is equals to A, and then 1 minus r to the exponent of n, and then 1 minus r. Our a value now is 36 pi, and then 1 minus our r value is 1 over 4. And then they said how many cycles? 10 cycles. So we're going to put 10 here. And then all over 1 minus 1 over 4. Now it's just a matter of punching all of this into your calculator. So your sum of 10 terms will be what? Therefore, the sum of 10 terms, if we punch all of that into our calculator, then what do we get? Let's quickly punch it. So we get 150.80 rounded off to 2 decimal places. Right. And that's it. That's it. Okay, then they say which circle has a diameter? Note that which circle has a diameter of 3 over 128 centimeters. Now, when they're talking about diameters, we know that diameter is twice the radius. So that means diameter of first circle. So let's say first circle will have a diameter of what? 12. And then second circle will have a diameter of what? So that means it's 6. And then that circle will have a diameter of what? 3. So that's how the pattern will go for the diameters. Okay, now they're saying which circle will have a diameter of 3 over 128. So that means we must create a pattern out of this. Now our R value will be what? T2 divided by T1. So we do understand that also this will form a geometric pattern. So 6 divided by 12, that's 1 over 2. That's our R value. Our A value is what? Is 12. Okay, so now what do we do? That means we are supposed to use Tn now. We are trying to find the n value for Tn is equals to 3 over 128. So which is a to the exponent of r, n minus 1. So this is now 3 over 128. Our a value is 12. Our r value is 1 over 2. And then here we have n minus 1, right? Now, what's the first thing that we are going to do? We can multiply both sides by the 1 over 12 so that we get rid of it here. So let's multiply both sides by 1 over 12. So the 12 will cancel out with the 12. But then here, when we multiply it, what is it going to give us? We are going to get 1 over 512 is equals to 1 over 2 and then n to the exponent of n minus 1. Now we can take this and write it in exponential form. Take the 512 equal and then say a shift fact, right, from your calculator. So you will see the 512 changes to 2 to the exponent of 9. So which means I can have 1 over 2 here and then all expressed to the exponent of 9. And then is equals to 1 over 2 to the exponent of n minus 1. Now the bases are the same. That means I do what? Drop the bases and equate the exponents. Drop the bases and equate the exponents. So I have 9 is equals to n minus 1. So transpose that over to this side. Therefore, my n will be equals to 10. So in other words, it's the 10th cycle that will have a diameter of 3 over 128 centimeters. Right. That's how you were supposed to calculate that. Pretty interesting question there. So all that for 4 marks. So it's a mark for having to write the expression as this. It's a mark having to equate to the general formula like that. And then having to simplify that to this. And then lastly, your final answer. Okay, so 10 marks in the bag, just like that. So make sure that you go through this question and understand it. Let's now go to question 4. All right, so we have this question 4 here. We are given an exponential function. We are saying given f of x is equals to a to the exponent of x minus 1 for where a is greater than 0. meaning it's positive, then your b value is 2 to the exponent. It's 2 to negative 5 over 9 as the coordinate is a point on F. Calculate the value of A. So for 4.1, this is what we are going to do. We are already given the coordinate. So that means where there's f of x, I can just replace by negative 5 over 9. And then where there's x, I can just replace by what? By 2. And then minus 1. Now it's just a matter of taking this over to this side. So negative 5 over 9. And then plus 1 is equals to what? A squared, right? And then when we punch that into our calculator there, we get that a squared here, this will give us 4 over 9. And then 4 over 9, if we square both sides, we know that we are going to have plus minus, but then remember they said where your a is greater than 0. So that means we must take the one that says positive. So that's positive what? 2 over 3. There we go. So that's your a value like that. Then 4.2 simply says write down the range of f. Now, how are we able to write down the range of f? Simply by looking at the asymptote here. We know that our exponential graph should be above the asymptote if our a has to be greater than 0 there. So that means we are going to say our range should be all the values that are greater than what? Than negative 1. If you prefer to write it like this, you want to say y is an element starting from negative 1 all the way to what? Positive infinity, right? So, right. 1 mark just like that. Then 4.3 says sketch the graph of f, clearly show the intercept with the axis and asymptotes if there is any, right? So now remember that since we know that since we calculated our a value and we found it to be a fraction, we know that the kind of graph that we should be expecting there, because this is where our a value is between 0 to 1. So we know that this is a decreasing function, right? So let's highlight our asymptote there in red. So our asymptote will be at negative 1. So negative 1 is our asymptote. And then this here is our original. So this graph must be coming all the way like this. A decreasing function. It must be a decreasing function. Oh, yes. Something of that nature. Yes. Something of that nature. Might be a little bit wide. So, yeah. So, this is our asymptote here, which is y is equals to what? Negative 1. And then that's all we show there. And then the coordinates of b might be found somewhere there. So, b is 2 is to negative 5 over 9. Okay, so that's all you do. That's all you indicate there. So we have the sketch there for 3 marks. Then 4.4 says it is further given that point C is a point on F at y is equals to 19 over 9. Determine the coordinates of the image of C. So this means image of C. When C is reflected about the line, y is equals to x. Now the line y is equals to x simply means this is where now if you find a coordinate, for example, let's say our coordinates are 2 is to 3. If we say this is reflected along the line y is equals to x, that means it's an inverse, meaning the image would now have to be 3 is to 2. This simply means your y will be x and your x will be y. So that is a reflection along the line y is equals to x. It is known as the what? As the inverse reflection. So this is the inverse reflection. So what do we do now? Obviously, we are supposed to first calculate the original coordinates of C. Then from there, we can reflect them. So, okay, we're going to say our equation. We have already got it. F of x is equals to what? So our equation, we said it's 2 over 3. So we have 2 over 3 to the exponent of x and then minus 1. But then remember, we are given that the y coordinate for C is 19 over 8. So I'm going to replace by 19 over 8 here. And then is equals to 2 over 3. And then to the exponent of x minus 1. Remember, we are dealing with the exponential function. So you might want to be tapped into your exponential laws. So transpose that one to that side. So 2 over 3. and then to the exponent of x. When we say 19 over 8 plus 1, this gives us what? Punch it into our calculator. 27 over 8 is equals to 2 over 3, and then to the exponent of x. Now let's look at a way in which we can write this in exponential form. If we say 27 equal and then shift factorize, then this gives us 3 to the exponent of 3. Again, if we do it with 8 equals shift factorize, we get 2 to the exponent of 3. Now we get that the 2 here, they share the same exponent, meaning they can be expressed as what? 3 over 2, all to the exponent of what? Of 3. According to the law that says if I have a to the exponent of m, b to the exponent of m, this can be written as a over b, all to the exponent of m. Right, so let me just show you the whole method here. So this, I change it to 3 to the exponent of 3. Then I change it to 2 to the exponent of 3. And then this is what? Now I want this to be the same format as that. Remember, here we have 2 over 3, but here we have 3 over 2. How do I ensure that I have the same base here? I can use a law of exponent that says if I want to change this, so if I have a over b to the exponent of m, I can write this as b over a by simply changing this exponent to a negative, right? So which is basically what I'm going to do. This is 3 over 2, but then I will say to the exponent of negative x, so that now I have the same what base. Now, this is what I'm going to do. I'm going to apply this law of exponents here. So when I write it as 3 over 2, all expressed to the exponent of 3. And then this is 3 over 2, all expressed to the exponent of negative x. But why did I want to have the same base? It's because there is a law of exponent that says in an equation, if the bases are the same, I can just do what? Drop the bases and equate the exponents. So we've been applying this law of exponents throughout this question. 3 is equals to negative x, and then therefore our x will be equals to what? Negative 3. And then that is our solution right there. But then remember, we are not done, right? We are not done. The purpose of all this from the beginning was to find the coordinates of c and then reflect them over the line y is equals to x. So that means our coordinates of c originally will be what? Will be negative 3 is 2, 19 over 8. But then the image now will be what? The image of c reflected along the line y is equals to x will now be 19 over 8 to negative 3, right? So negative 3 to 19 over 8, that's the original coordinate of c. And then the image is 19 over 8 to negative 3, right? Which indicates that we have reflected over y is equals to x, because now our y value becomes the x value and our x value becomes the y value. That's it. That's how you were supposed to approach that question. All for a total of 9 marks, right? So let's now move to question 5. Okay, so we have question 5. It says sketch below is the graph of f of x is equals to a over x plus p plus q, having the domain negative infinities to 1, and then 1 is to positive infinity. So, okay, this basically means it's from negative infinity to positive infinity, where x should not be equals to 1, because that would be your asymptote. The graph of f cuts the y-axis at 0 is to 1. A line of symmetry of f is given by g of x is equals to x minus 3. Then we are given that graph there. 5.1 says write down the value of p. Now to crack the value of p, just simply look at your vertical asymptote here. So we see that the vertical asymptote is positive 1. But then remember, in order for it to become a positive 1 here, we need to take this and equate it, right? So that means your p value here would have to be what? Negative 1. So if we say x and then our p, let's say it's negative 1, let's see if it's going to give us the vertical asymptote. Remember, how do we get the vertical asymptote? By saying x plus p equal to 0. So we are saying our p should be negative 1. So x minus 1 is equals to 0. Then our x is equals to 1, which would represent the what? the vertical asymptote. So in that case, that's how we were able to conclude that our P needs to be what? -1. Because our vertical asymptote was positive, therefore P here would have to be substituted as negative. So note that trend. So 5.1, that's our P value. Then determine the equation of the horizontal asymptote of F. Remember, we are given the line of axis of symmetry, and we know the line of axis of symmetry, that's where we have the intersection of those, asymptotes, right? So this is the line that we are talking about. And if we can look at the point of intersection here, we can see that this point of intersection is with our axis of symmetry. So if we can use this coordinate here, that means we can be able to get the what? The horizontal asymptote. We use this coordinate 1, x is equals to 1, on which equation? On x minus 3. So we are going to say 5.2, we have g of x is equals to x minus 3. And then what do we do? So where there is x, let's substitute 1. You don't substitute -1, you substitute 1, the vertical asymptote, so that you can find the horizontal asymptote. So that's 1 minus 3. And then this will give us what? -2. So that means the coordinates of the horizontal asymptote, or we are supposed to give the equation. So that's y is equals to -2. Right. Then we have 5.3. It says calculate the value of A. Calculate the value of A. Now we can see that since we have, so this is f of x is equals to A over x plus P and then plus Q. Now we did calculate the value of P, it was -1. We calculated the what? The horizontal asymptote, which we do know that the horizontal asymptote is exactly the same as the value of Q here. So what we got as our vertical asymptote was -2. So that means our Q should be -2 as well. So now that we have that, we can use these coordinates that we are given here, 0:1, in order to calculate the value of A. So let's use 0:1 as our coordinates for y and x. So that means where there is y, f of x, I'm going to put 1. And then I have A here. Where there is x, I'm going to put 0 as that coordinate. And then what's my P value? It's -1. And then what's my Q value? It's -2. I'm going to take this and transpose it over to that side. That's 1 plus 2, right? Now, 8 divided by 0 minus 1. 0 minus 1 is -1, so this will give me -A. So 1 plus 2, that's 3, and then -A. If I swap this once, my A will be equal to -3. Okay, so there we go, Right, now 5.4, so this was 5.3. 5.4 says, for which value of x is f of x greater or equal to 0? Now let's interpret this. What does this mean? It means, where is our graph of f? At the x-axis or above the x-axis. So the meaning of this is we are looking for where the graph of f is exactly at the x-axis or above the x-axis. Now, let's investigate that. If we are to check this part here, we can see that our graph of f is actually below the x-axis. Let's first highlight the x-axis. So the x-axis is this blue line that I'm drawing here. Yes. So that's the x-axis. So we want where the graph will be above that point. Okay, so definitely not there. And then what about here? Is it above? No, it's below. So definitely not here. But then when we look at this part here, exactly, it is above the x-axis. So starting from which point? Starting from when x is 0 all the way to when x is just before +1. Remember, it won't touch, the graph won't touch +1 because +1 is what? Is an asymptote. So how should this be written? This should be written in this fashion, right? So, okay, this is not exactly at 0, pardon me there. So it is at this point here, which we should still look for. right? It is at this point which we should still look for. Then to look for that point, we can see that this point is actually a what? An x-intercept. So how do we calculate x-intercept? For x-intercept, we know that we have to make y0. So we want to take this equation now. This is f of x is equals to, so let me erase here. So f of x is equals to -3 over x minus 1, then minus 2. So we are looking for the x-intercept. We make y0. So 0 here, -3 over x minus 1, and then minus 2. And I take this minus 2 and transpose it over to this side. That's 2, and then -3 over x minus 1. When we cross multiply here, that's 2x minus 2 is equals to -3. Now this will be 2x is equals to -3 plus 2. Then we have 2x is equals to -1. Divide both sides by 2. Then our x should be equal to -half, right? So that means the point here, the x-intercept that we have here is -half. So it makes sense because we can see it's just a little over the origin here. So the origin 0 is here, and then this is just a little over there. Now, we said it's between this point and +1, but not touching +1. So that means the way we should be writing our answer is to say this is within x, an element of what? Square bracket, -half. Why are we including the -half? Because also at that point, it is exactly at the x-axis. Remember, we said the interpretation of this is that it must be at the x-axis or above the x-axis. So at -half, we can see the graph is exactly stationed at the x-axis. So we want to have -half all the way to what? To 1. But then when I write 1, I'm going to use what? Round brackets, because 1 should not be included into the critical values, because it actually is an asymptote. Your graph will not touch them. Or another way of writing it is to say x here, and then greater or equal to -half, but less than 1. So it's up to you how you actually want to write it. But then, yeah, that's how you were supposed to get that 3 marks there. So it's a mark for the x-intercept. So they gave 1 mark for the x-intercept, and then they gave 2 marks for your solution here. So 2 marks for your solution. Right, so 3 marks like that. Nice. Okay. Right, then we have 5.5. It says graph f undergoes a transformation to h where the domain and range of h are the same as that of f, right? So they're mentioning that the domain and range of h would still be the same, even if this transformation takes place. But then h prime x, which is the derivative of h, is negative on its domain, right? So they say describe a possible transformation that f could have undergone to result in h. Okay, so the range, let's start by the range of f. The range of h, the range of f originally is what? So remember, we have our f of x is equals to -3, x minus 1, -2. So the range would be what? Y is an element of real numbers where your y should not be equals to -2, right? And then your domain of f would be x is an element of real numbers where your x should not be equals to what? +1, right? So this is what we have. Now, if we are to create an equation of h whereby we must still keep the same domain, so we're going to say h will be -3. So let me start by trying to reflect this along the x-axis. So I'm just doing trial and error here, because most of the time, if this remains the same, it's a reflection along the x-axis. So that's -x and then -1. Remember, a reflection along the y-axis Okay, so we say most of the time it stays the same when it's a reflection along the y-axis. So let's try reflection along y-axis, right? So that's negative 3 over x minus 1 and then minus 2. So what will happen here is that I would have to factor out this negative. So I'm going to have negative 3 and then negative bracket x. This one would have to be plus 1 and then minus 2. Now the negative and the negative will form a positive here. So we have positive 3 over x plus 1 minus 2. But note that this now changes the what? This now changes the domain, because now the domain will be x element of real numbers where x is not equal to negative 1, which is no longer the same. So that means, what would I have to do here in order that I still have the same domain? That means in order that I still have x minus 1 here. So what I can try to do is I can shift this 2 units to the right. Remember, 2 units to the right means I come here and say minus 2. And then this is minus 2. And then my h of x now will be what? Positive 3 over x minus 1 and then minus 2. Right. So in that sense, that means if I reflect it over this side, then this becomes what? So it becomes something like this. Something like this. Something of this nature. Yeah. Almost like this. So that would be a reflection along the y-axis and then a shift 2 units to the right. Okay, yeah. Hope so. So, okay, how do I then define that? I would say this is a reflection along y-axis and translation 2 units to the right. Okay. You let me know your thoughts on how you were, how you could have answered that question. But then there are so many options. Even the memo gives a lot of options, about 4 options in which you can actually arrive to that answer there. So you can actually share which one did you use there to get that. So yeah, this question was open for a lot of methods in which you can use to land up to that. Right, so let's proceed to the next question. Okay, so now we have question 6. It says, in the diagram below, the graphs of f of x is equals to negative x squared plus 4x plus 5 and g, a straight line are drawn. Then we have coordinates here, which are 3:8 at C, so which is a point of intersection between graph f and g. And then EH is drawn parallel to the y-axis, with E a point on F and H a point on G, right? Then 6.1 says calculate the coordinates of B, which are the turning point of F. Now, obviously, this is a classic question. We know that if we want to calculate the coordinates of the turning point, given that, we have to apply the axis of symmetry formula. So we start by getting the axis of symmetry using x is equals to negative b over 2a. Now we know that our value of b is that one. So we have negative and then put the value of b. Our value of a is the coefficient of x squared. So this is 2 to the exponent of negative 1. 2 bracket negative 1. So that's a negative 4 divided by negative 2, which will give us 2. But after we've got the axis of symmetry, we know this is the x coordinate of point B. So, right, it's 2. So that means now we have to find the y coordinate by taking this 2 and substituting it back into the original equation. So where there's x, now we're going to put the 2. So that's 2 to the exponent of 2 plus 4 multiplied by 2 and then plus 5. Now, if you punch all of that into your calculator, what will you get? So you'll get 9, right? So that means your coordinates of B are actually 2 is to 9, right? So you get yourself 3 marks like that. Okay, nice one. So for the method of x, that equation, and then you have your x coordinate 2, and then you have your y coordinate right there. So, right, 3 marks like that. Now show that the equation of the line through A and C is given by g of x is equals to 2x plus 2, right? So, okay, so we are supposed to find the equation of the straight line AC here. So we already have the coordinates of C. That means we would have to find the coordinates of A. But then now we understand that A is actually an x-intercept. So in order to find the x-intercept, we have to make y 0. But on which equation? Remember, we don't have the equation of a straight line, so we have no other choice but to use the equation of the parabola there, right? So this is how we're going to go about it for our 6.2. We have our f of x is equals to negative x squared plus 4x and then plus 5. Remember, with the x-intercept, you make your y 0 or your f of x equal to 0. Then you want to put 0 here. We have negative x squared plus 4x and then plus 5. Now, what do? Divide throughout by negative 1. So this is going to be x squared minus 4x minus 5 equal to 0. 0 divided by negative 1 is still 0. Then at this point, what do? We can factorize here. Factors of 5, we know it's only 1 and 5. So let's put 1 here, let's put 5 there. But then based on this, we know that the one that should have a negative is the bigger one, right? Because it's the sign of the middle term. So negative here and then positive is equals to 0. So our x is either equal to negative 1 or our x is equals to 5. Now, based off of this, we can tell that the D is the one that is supposed to have 5, positive 5. And then A, because it's here on the negative x-axis, it is the one that should have negative 1. So we want to go with this one now. So we want to go with that one. And then we say, therefore, our coordinates of A are actually negative 1 is to what? 0, right? But then remember, we are not done. The main objective here is to find the equation of AC. So we wanted to find the coordinates of A so that we can calculate the gradient of AC. So to calculate gradient of AC now, I'm going to say y2 minus y1 over x2 minus x1, right? Then we have what? 8 minus 0 over 3 minus negative 1, which if we punch all of that into our calculator, we get our gradient is equals to 2, right? So to then complete the equation, we are going to say this is y minus y1 is equals to m, x minus x1. So we have our y. Let's use the coordinates of A, minus 0. And then gradient is 2. And then we have x. This is negative 1 here. So negative and negative will be plus 1 here. And then we have y is equals to 2x plus 2. There we go. That's our equation now. So what I did is multiply inside by the 2. So 2 multiplied by x, 2x, 2 multiplied by 1 is 2. Okay, so just like that, you have earned yourself 3 marks, right? So it was just 1 mark to find the coordinates of A, and then the other 2 mark was distributed into the gradient, and then also having to find that equation. So substituting the point of A or C to find the equation. So right. Okay, then we have 6.3. It says calculate the maximum length of EH for F is above G, right? So this means where F is above G. As we can see here, this is the graph of F. Let's highlight it in red. So that's where point E is. So at that point, we can see that the graph of f is actually above the graph of g, which is what they're saying there, right? So at this point, so we are supposed to calculate the maximum length, for which if we can put point E above point H, we will have the maximum length possible, right? So this is where we need to apply the concepts of calculus, right? Then what we are going to say is, if we are to express this, if we wanted to find EH, we understand that we would take, remember, for the vertical distance, I've taught that you must say y at the top minus y at the bottom, right? So we do understand that if you were to calculate EH here, you would have to say y at the top minus y at the bottom, but the y at the top is represented by the equation of f of x, and then the y at the bottom is actually represented by the equation g of x. Hope it makes sense. Remember, f of x is still the same as y, and then g of x is still the same as y. So it's like I'm taking the y coordinate of E and then minus the y coordinate of H. That will give me the distance between the two. So, okay, but then now, let me write that in terms of the expression. F of x is negative x squared plus 4x plus 5. I'm writing this because I don't actually have the actual values here. If I had actual values, I would just take the value here minus by the value here. But since I don't have values, I now need to represent that in terms of x, right? So that's minus bracket 2x plus 2. Remember, we have now calculated the equation of g of x. Now this is going to be negative x squared plus 4x minus 2x and then plus 5 minus 2, which is going to give me negative x squared and then plus 2x and then 5 minus 2. This will give me 3. So this is EH in terms of what? In terms of x. But then we do know in calculus, once they speak about maximum or minimum, that's where now we have to show the derivative, right? So remember, the maximum or the minimum points can be found when you do the first derivative. So that's where we apply that. So we want to say EH prime x. So this is going to give me negative 2x and then plus what? Plus 2. Now remember, when we derive, we should equate to 0 because again, the maximum length or the minimum length in cubic functions actually represents the stationary points. And at the stationary point, we usually say the gradient there is 0. So remember, derivative means it's the gradient formula. So what is the gradient at maximum points or minimum points? The gradient at maximum points or minimum points is actually 0. Hence, we always equate by 0 if we want to find the maximum or the minimum. So 0 is equals to negative 2x and then plus 2. Now we can take the negative 2x over to this side. We have positive 2x divided by equal to 2. Then we're going to divide both sides by 2. Now our x is equals to 1. So what does this x is equals to 1 represent? It represents the position whereby you would need to put your E and H so that you find the maximum length possible. So that means where they've put E and H, the x coordinate has to be 1. But have we found the maximum length? No. We have just found the position where the maximum length will occur. So if we want to find the maximum length, what do we then do now? We must then come over here and say our length for EH is represented by that equation, right? So that means where there is x, now let me put that 1. So this is 1 square plus 2 multiplied by 1, then plus 3. Now if I substitute that, that means that the value that I'm going to get represents the maximum length of EH that can be formed at the position where x is equals to 1. So when I punch that into my calculator, I get 4. So that means the maximum length possible would be 4 units. I hope that makes sense. So it would be a mark for having to find the difference there, right? So, and then, so being able to say that f of x minus g of x represents EH, then after you have found that standard form equation, it's another mark. And then finding your x value, it's a mark. Then finding the length, it's also another mark. So 4 marks like that. Okay, then given k of x is equals to fx plus m is equals to negative x cubed minus 2mx minus m squared plus 4x plus 4m plus 5. Determine the value of m such that g is a tangent to k. Such that g is a tangent to k, right? Now, if g is a tangent to k, it would mean that at that point, they will intersect. Remember, if you have to draw a tangent anywhere, right? You have to draw. So this is saying k is actually formed by shifting the graph of f m units to the left plus m, right? M units to the left. So that means if I were to draw a tangent anywhere else, right, it would have to touch with that graph. So meaning that I would have to use the concept of point of intersection, whereby I would have to equate the equation of g to this equation of k of x here, right? So, okay, first thing. So there will be a point of intersection between k of x and g of x. So that means I must have what? K of x is equals to what? G of x, right? But we do know that k of x is actually this, right? So, which is that whole expression. So I'm going to have negative x squared minus 2mx minus m squared plus 4x plus 4m plus 5 is equals to what? The equation of g of x is what? 2x plus 2. Then I'm going to have negative x squared minus 2mx and then minus m squared plus 4x. Then let me take this over minus 2x and then plus 4m plus 5. And then let me take this over minus 2 is equals to 0. Right. Then from here on, I'm going to have my equation as negative x squared minus 2mx minus m squared. This here will give me plus 2x and then plus 4m. Then 5 minus 2 will give me 3 is equals to 0. Okay, so at this point, what do we do? If I just divide throughout by negative 1, so that I keep this one as a positive, this will be positive x squared plus 2mx plus m squared minus 2x minus 4m and then minus 3 is equals to 0, right? So at this point now, what do I then do? I can just group this, right? So let me group this. So with this one, I can see that, okay, we have a common factor of m, right? We have a common factor of m. And then let's see. So all of these ones, no common factor between them. Okay. So let's say we have x squared and then plus so common factor of m, but then this and that has a common factor of x. So if we follow ax squared plus bx plus c, so I want to get it into this format. What can I do? What can I do? Okay, let me just take this one. Let's follow, guys. I'm going to take this and that. So just allow me to swap these ones. So I have negative 2x, and then I have plus m squared here, so that I deal with this common factor of x here. So this is what I'm going to do. I'm going to say I actually have 2m minus 2, and then factor out this x, right? Then whatever that's left here is m squared minus 4m, and then minus 3. So I'm just going to take all of this as c. So follow this here will be one thing. There will be another thing. coefficient of x, and then all of this would be c. So what is the coefficient of x squared here? That means my a is equals to 1. What is my coefficient of x? That means my b here is 2m minus 3. What is the constant? The constant would have to be everything that does not include c. Everything that does not include, that does not include x. Everything that does not include x is the value of c. Okay. So, okay, now I want to use the nature of roots. We know that the graph and the intercept will only, the graph and the tangent will only intercept once. If it intercepts one, it means it has one root. One root. Now, according to our discriminant, if we have one root, that means our discriminant should be equal to 0. Discriminant, remember, is b squared minus 4ac. So my b squared minus 4ac should be equated to 0 because there is only one root. One root. So, okay, that means this is what I'm going to do. Yeah, so this was a crazy 5 marks, guys. Hey. Crazy 5 marks. So this is what I'm going to do. Going to say this is a b squared minus 4ac equal to 0. Then where there is b, so let me just erase here. I hope we have noted down. One of the craziest question last year was this one. Then we have our b squared minus 4ac is equals to 0. So you do these ones if you are looking for your 90%, 100%. Then this is 2m minus 2 square minus 4. Your a value is 1. Your c value, remember, it's that m squared minus 4m and then minus 3. Now, remember to equate that to 0. Right, so we must do the math for all of this. So that will give us 4m squared minus 8m and then plus 4. And then here we're going to have what? Negative 4m squared. And then negative 4 times negative 4, that's 16m. Then negative 4 times negative 3, that's 12, is equals to 0. Now, what happens is that this must cancel out with that. And then now we have other like terms, negative 8 plus 16m. So negative 8 plus 16m would have to give us positive 8m. Then 4 plus 12 would have to give us 16. And then equal to 0, we have 8m is equals to negative 16. Divide both sides by 8. Then our m is supposed to be equal to what? Negative 2. Damn. That's how you were supposed to solve that one. Right. Yeah. So there was a crazy 5 marks. There was a crazy 5 marks. So you got a mark for equating. You got a mark for simplification of the equation. So equating means equating it to 0 because you understand that you are looking for where the discriminant, or equating, number one, equating would mean equating the graph of f and the equation of f, or the equation of k of x here, and the equation of g of x. That's a mark. And then having to simplify that up until the point whereby we had this. That's another mark, right? And then from there on, equating that expression as a discriminant here to 0, because you understand that there will only be one root. That's the third mark, right? So here, this is the second mark. This is the third mark. And then, so here, equating, fourth mark, and then your answer is the fifth mark. Okay, nice one. Crazy. Let's proceed to the next question. All right, so we have question 7. financial maths, it says Mary's grandparents deposited 5,000 into a savings account on the day that she was born. The account pays interest at a rate of 6.8% per annum, compounded quarterly. Calculate the accumulated amount in this account on Mary's 16th birthday, right? So as we can see here, the 5,000 is actually just deposited once, right? So it is not a regular installment. So that means this is just lump sum saving. So what do we do in that case? It means that all we just have to do here is use the compound formula, right? So no future value formula here. This is A is equals to P, 1 plus I to the exponent of n, where your P value will be the 5,000. You have 1 plus the interest 6.8% is going to be 0.068, but then divide that by what? By 4, because it's quarterly. Then this is for 16 years, so it's 16 multiplied by 4, right? Then all you have to do is punch all of that into your calculator. You get 14,706.56, right? So 3 marks just like that. Formula, substitution into the correct formula and the correct answer. Then we have 7.2. 7.2 is saying, after 4 years, the value of a printer was half of its original value. The value of a printer of which we are not told. So let's take the value of the printer initially as X, and then after 4 years, it depreciates to half of its original price, which is half X. Determine the rate at which the value of the printer depreciated over this period if depreciation was calculated according to the straight line method. Remember, the straight line method is A is equals to P, 1 minus I, multiplied by N, right? So our accumulated amount now is what? Half X. Remember, it will depreciate to its half. It will depreciate to half of its original value. So P represents the original price, and then A represents the book value, right? Then this is equals to what? X. 1 minus I, which is what we are looking for, but then the number of years is 4 years. So with this one, it's not quarterly, it's not monthly. We know that depreciation occurs on a yearly basis, right? So we want to divide both sides by X like that. And then we have half here. We have the 1 minus 4I, and then we can take the negative 4I over to this side. Then we're going to have 1 minus half. So this is going to be 4I. 1 minus half is 0.5, and then divide both sides by 4. So we are going to have I is equals to 0.125, right? Then obviously we know we should not leave it like that. If we want the rate, we should then multiply by 100, right? So that means the rate of depreciation now is going to be 12.5%, right? So that's how you are supposed to indicate that. So because it's rate, let me put R. So 12.5%. Right. So, okay, that's it. 2 marks, only 2 marks, guys. Okay, so it's just the substitution into that formula and then also the final answer. Okay, then we have 7.3. They say Tepo was granted a loan of 100,000 on 1 March 2022 at an interest rate of 13.5% per annum compounded monthly. Tepo agreed to repay the loan over 5 years in monthly installments of 2,300.98 starting on 1 April 2022, which is just a month after he took the loan. Calculate the total interest that he will pay over the 5 years, right? So obviously, this is what we are going to do. So for interest, we know that interest is just simply, we have to take nx minus by the present value, right? So the present value is the loan amount, right? So, but then this represents the period multiplied by the, what you call the monthly installments, right? So we are going to say 5 years, it's how many months, right? Because remember, this 2,300.98 is being deposited on a monthly basis. So 5 years, that would have to be 60 months. multiply that by the 2,300.98 minus the what? The present value of 100,000. So note this formula here. This is the formula to calculate the interest on a loan, right? This is the formula to calculate the interest on a loan that is being paid by regular installments, right? So when we do that, we are going to have what? So for this one, that's 138,068.80, then minus the 100,000, which is going to give us what? 38,068.80. Right. So for 2 marks, that's what we were supposed to do. Right. Okay. Okay, so we have 7.3.2. It says Tepo paid 22,300.98, which they got this by adding his monthly installments of the 2,300.98 and an additional 20,000 that he makes, right? So all in all, if you say 2,300.98 plus the additional 20,000 lump sum, remember the 20,000 is only being paid once on 1 March, right? 2024. So remember, when we go back here, they said Tepo was granted a loan of 100,000 on 1 March 2022. And then he decides to pay that extra 20,000 on 1 March 2024, which is exactly 2 years after the loan has been granted to him. Into the loan account, he continues to pay the original month installments thereafter. So after that 20,000 lump sum, he still continues to pay the 2,300.98. Now, first, let's understand what is being done here. So Tepo is just trying to amortize the loan in a shorter period, right? It's trying to pay off the loan in a shorter period. So that's why now he's throwing in the 20,000 to actually save himself from interest and also not to take this whole loan for the whole 5 years, right? So it's trying to complete it in a much lesser time. Now they say how many months earlier do you see that? How many months earlier will Tepo repay the loan? Which means it will no longer be exactly the 5 years, which would actually mean it's what? Is it 5 multiplied by 12? That's 60, right? 60 months. So that means it will no longer be what? Be 60 months, but then it would have to be less than that, right? So now this is what we are trying to find out now. How many months earlier will he repay the loan if he makes that lump sum payment of 20,000? So this is what we are going to do. This question, we're going to start by first finding the outstanding balance after he has paid for 2 full years, right? So this is what happens. When I say present value is x1 minus 1 plus I to the exponent of negative n over I. And then we say the x amounts were 2,300.98. Then bracket 1 minus 1 plus the interest is what? 13.5%, which can be written as 0.135 monthly over 12. Then if we are calculating the outstanding balance, let me indicate this as OB, the outstanding balance. Remember, if I'm calculating the outstanding balance, I have to consider the outstanding number of months. So for 2 years, that's 24 months. 24 months have already been paid for, right? And then the outstanding are these ones. So the outstanding number of months are this. So from 24 to 60, we get that 60 minus 24, that would leave us with an outstanding months of 36 months, which is 3 years, right? Okay, then over what? Over 0.135 over 12. So the n here has to be what? Has to be 36. So these are the outstanding number of months in order for the loan to be completed, right? So we are still assuming that if he did not pay the 20,000, then how much would be left, right? If he did not pay the 20,000, how much would be left? So outstanding balance is this. So the outstanding balance after 2 years of full payments is 67,804.94, right? But then remember, on that month, right, on that month of March, 2024, he actually did something. He paid a lump sum of 20,000. So that means now the outstanding balance would have to be 67,804.94 minus the 20,000, meaning that we are now left with what? To pay off the loan, we are now left with 47,804.94, which is now the new outstanding balance after he makes that lump sum payment of 20,000. So now we want to take this and continue with it and see how many more months will it take for him to pay off the 47,804.94 now, not this, right? If you were to continue paying this, that means it will take him the whole of the 3 years here, the whole of this 36 months. But now, because we have made a payment of 20,000 and then we are only left with an outstanding balance of this, that means it will take us fewer months now. Okay. So what do we then do? Now that we have this, come back again and calculate with the same formula, right? So we are now going to say, to continue with that, present value is x, 1 minus 1 plus I to the exponent of negative n over I. Now our present value, which is our outstanding balance, is 47,804.94. Remember, he still makes those monthly installments of 2,300.98. And then we have 1 minus 1 plus 0.135 over 12. But this time around, we are looking for that n. We are looking for how many number of months it will take him to pay. 135 over 12. Then cross multiply here. So you do your maths here. So you just have to sharpen your math skills when it comes to this one. So a quicker way to do it is this. So just simply cross multiply this and then divide that. And then take this 1 over to this side. Minus 1 is equals to negative 1 plus 0.135 over 12 to the exponent of negative n. Right? Then what you can then do is swap these ones around. So 1 plus 0.135 over 12 to the exponent of negative n is equals to, so when you swap them around, they actually become 1 minus 47,804.94, and then over what? Bracket 0.135 over 12. So I'm doing this because financial math is very, very sensitive to rounding off. So you must make sure you keep your values like that. We are dealing with money here. So, okay, then from there on, that's where you need to actually punch all of this into your calculator. So you'd have your n is equals to negative log, and then take all of this, 1 plus 0.135 over 12, and then take all of that. So the answer to all of that, which is going to be, so if you punch this into your calculator, it should give you something like 0.766 something there, right? Then punch all of that into your calculator. You get that your n is equals to 23.80, which in conclusion, we can say that is approximately 24 months, right? Now, 24 months is the time it will take Tshepo to pay off the remaining amount, the outstanding balance, right? But then remember, we had calculated that if it wasn't for the 20,000, it would take him 36 months. But now with the 20,000 that has been thrown in, it's now only 24 months to pay off the remaining balance or the outstanding balance. Remember, the question is how many months earlier will Tshepo repay the loan? It's not 24 months earlier. We have to then say 36 minus 24. It means it will be 12 months earlier, because now instead of the whole 36 months, he's only taking 24 months. So that means that's actually 12 months earlier. Right. And that's how you were supposed to solve that question. So this was a very nice question. This was a very, very nice question from last year. So make sure that you are actually mindful of that question. Practice this question. I don't believe there is any other question that might give you a problem. Hello, hello. All right, so we have question 8. It says determine d of dx 3x minus 5x squared. So we derive this in terms of x, right? So what we are just supposed to do here, 8.1.1, this is already in a standard form. So all we have to do is the derivative of 3x is 3. The derivative of 5x squared, we say 2 multiplied by that negative 5 is a negative 10, and then we have x. So we are done just like that, 2 marks. So remember, they mark each derivative value here. Okay, then we have 8.1.3 says find g prime x if we have this. Now with this one here, we have to actually see that we need to rearrange it for derivation first, right? So prepare it for derivation. Remember, we cannot derive while our variable here is still on the denominator. So we have to bring it up to the numerator, and then we know according to the laws of exponents, how we bring it up is by saying x and then make the exponent to be negative, right? Then also again, this one cannot be derived while it is still in SAT form. So to take it out of the SAT, we have to say negative x, and then we have the 7. Since this is a cube root, it has to be 7 over 3, right? And then at this point, since everything is now in standard form, that's when now we can start deriving. So we change the g of x to g prime x now. And then this is going to be negative 2 multiplied by 2, that's 4. And then subtract 1 from that exponent. So this is going to give us what? Negative 3. And then right here, 7 over 3 multiplied by negative 1. That's negative 7 over 3. And then we have x, 7 over 3 minus 1. That is supposed to then give us what? 4 over 3. And then voila, we have derived just like that. So, okay, it was a mark for having to rearrange this to this and that, and then a mark for this and that. So 4 marks. Okay, then now we have 8.2. It says determine the equation of the tangent to f of x is equals to x cubed minus 4x squared plus 2x plus 3 at x is equals to 2. So we already know to determine the equation of the tangent is in the form of y is equals to mx plus c. We would need to find the what? We would need to find the gradient, and then we would need to find the coordinates that would match up there so that we calculate this. So the first thing that we can do now is let's find the coordinates, right? So at x is equals to 2, we know that the tangent and the equation of f of x, or the graph of f of x, would have to have a point of intersection. So where the tangent is, it will meet with the graph of f. So meaning at that point, they will share the same coordinates. So what is the y coordinate when x is equals to 2? I'm going to put 2 here, cube minus 4, 2 square, and then 2 multiplied by 2, and then plus 3. And then when we punch all of that into our calculator, what we end up with is that this will be negative 1. So our coordinates will be 2 is 2, negative 1. Now the next step is to find the gradient. How do we then find the gradient? Obviously, the gradient will be found by doing the derivative equation, which is your gradient formula. Then this is going to be 3x squared. This will be negative 8x. And then this here will be plus 2. But then remember, this tangent is occurring at x is equals to 2. So I'm going to find the gradient of the curve when x is equals to 2. And then that gradient at that particular point will be equal to the whole gradient of the tangent line. Okay, so basically this is what we are saying. We are saying if this one touches at a particular point here, it means that the gradient of the curve is exactly the same as the gradient of the whole tangent line. right? So when we punch all of that into our calculator, we find that it's -2. So that means the gradient of the tangent is also -2. So now to then calculate our equation, this is y is equals to mx plus c. So my y coordinate, -1, my gradient, -2, my x is 2, and then plus 2. Then this is -1 is equals to -4 plus c. C is equals to what? 3. If we take the -4 over to this side, that's -1 plus 4, which will give us 3. That means our equation is y is equals to what? Gradient is -2x and then plus 3. Right, there we go. So we are good with that one. We are good with that one. So how did they mark this one? For finding the gradient, it was a mark. For finding the y coordinate, it was a mark. And then lastly, for having to find the equation. Right. Let's now proceed. We have 8.3. It says, given f of x is equals to -6x squared, determine f prime x from first principles, right? From first principles, we know that this is what we do. So we have our f of x first is -6x squared. Then what will be our fx plus h? It's going to be -6x plus h and then square. Then we can continue to expand this one, which always becomes x squared plus 2xh and then plus h squared. Then if you multiply inside by this -6, that's -6x squared minus 12xh minus 6h squared. So this is the whole expression of fx plus h. But then remember, our equation to calculate f prime x is this. We say is equals to lim h approaching 0, fx plus h minus fx, and then over h. Then this is going to give us lim h approaching 0. And then let's replace this by the expression of f of x plus h, -6x squared minus 12xh minus 6h squared, then minus the expression of f of x, which is only just -6x squared over h. Right? Now what happens is that this will obviously cancel out with all of that because negative and negative will become positive. So, yep. Then we have lim h approaching 0. Then we are left with -12xh minus 6h squared over h. But then now if we can factor out the h as a common factor, so we have h, and then this will be -12x, and then minus 6h, then over h. Why do we do that? It's because we want to cancel out with the h that is on the denominator here, right? So now we have that expression on the numerator, and now I can drop writing this because where there's h, I'm now going to put 0. So -12x minus 6, and then h has now approached 0. So I'm going to put 0 there. And then therefore my f prime x will be equals to what? -12x. Right. Now, if you want to confirm if you have the correct answer, you can just derive this according to your rules, right? So with rules, you would just say 6 multiplied by -12. 6 multiplied by 2 multiplied by -6, which will be -12. And then 2 minus 1, which is just 1. So that's it. That's the same answer that you get, even if you are to derive using the rules, right? So remember, the first principle is just a longer way of doing it, right? That's like the same as doing your long division method, long multiplication method, right? Okay, nice one. Then they say 8.3.2, write down how you will restrict the domain of f such that the inverse of f is a function, right? Such that the inverse is a function. Now, remember, you can restrict this in many different forms. It's up to you. You can say, remember that the restriction can either be x greater or equal to 0, or it can be x less than or equal to 0, right? So we can see that what we are given here is actually a parabola, right? This is a parabola. You can restrict, because the domain, remember, what we have here is something that would be like this. Something that would be like this. Now, as an inverse, it can either be like that, right? It will be like that, whereby now you have to understand that you can either restrict this part so that it becomes a function. Remember, it's not a function when it's like this because it doesn't pass the vertical line test. It fails the vertical line test because if you put a vertical line here, it actually intersects twice with the graph. And then if we say the vertical line intersects twice with the graph, we say that graph is not a function. So in order to make it a function, that's where you need to come and cancel off one part, right? So to then deal off with one part there, you would have to say, if I take out this part, for example, then it will only intersect once with the vertical line, meaning it's a function, right? So you can either take out this part or you can take out the part that is down there. So, okay, in my case, I would have to go with x less than or equal to 0 because I'm simply taking where my x values are what? Are negative. So this is how I would actually restrict this, right? This is how I would restrict that so that the inverse becomes a function. So I would say x less than or equal to 0. So these are the values. Then, okay, determine the equation of the inverse for where the inverse will be less than or equal to 0. Write down your answer in the form of y is equals to. So, okay, for that one, we're going to have 8.3.3. This is y. So let's start with y is equals to negative 6x squared. And then for the inverse, we let y be equals to x. So put x here and then put y here. So where there's x, put y. Where there's y, put x. Then remember, we have to make y the subject of the formula, right? So that means I will have y squared is equals to negative 1 over 6x. This is the same as x over negative 6. So it's negative 1 over 6x. But then this is what I then do. Square both sides, and then my y is equals to plus or minus negative 1 over 6 and then x. But then remember here they said this must be less than or equal to 0, right? Less than or equal to 0, meaning it would have to end up being what? Negative. So that means I would go with y is equals to negative root 1 over 6x. And then remember from the previous question, I said I am actually going to take the restriction as x is less than or equal to what? 0. So which makes sense now because if I keep my x values as negative, that's the only way I'm going to get answers here. If my x would be positive, that means everything here will just give me maths error, right? So hence my x here has to be less than or equal to 0, right? So that's how you were supposed to go about that one. So that was a question that involved the inverses of the parabola, not a common question, but then you can see that it popped up. So it's very, very crucial that you go through those ones. So I will also link up a video about the inverses of the parabola on this video right here, on the description of this video. Okay, so we have question 9 on the cubic function. It says, what is 2, 9, which is your coordinates for a and b, 5 over 2 is to 8, are the turning points of graph f below. So we can see that both a and b are stationary points. And then we have 0 is to 7, which is the y-intercept. So there is it. For which values of x is f decreasing, right? So where is it decreasing? We can see that the graph is actually increasing all the way here. So it's increasing, but when it gets to that point, that's the stationary point, and then it starts decreasing all the way up until this point and continues to increase after that point. So it's increasing between these x coordinates here when x is 1 and then when x is 5/2. So how are we going to write that? We are going to say for x greater than 1, but x has to be less than what? Than 5/2, right? So that's how you write that one. Or you can say x is an element starting from 1 all the way to 5/2, however you prefer to write it. Then 9.2 says write down the x-intercept of the derivative of f, right? So, okay, for the derivative, then this is what we need to understand. Note that if we are to draw a derivative here, graph, the derivative graph would have to be like this. The intercept corresponds to the coordinates, to the x coordinates of the turning points, like that. So note again on my video on the relationship of the cubic function and the parabola, right? The secrets of the cubic function. Now, that means our x-intercept would have to be what? If this point would have to be here, that's 1:0. And then this point over here, that's 5/2:0. Then we are done just like that. Okay, then for which values of x will f be concave up? Now we know with this one here, if we are to deal with concavity, for the concavity, we need to know the point of inflection, right? But then you will remember that I said that the point of inflection is just simply, the point of inflection is the same as just calculating the midpoint of the x coordinates of the stationary points. So we have 1 and then 5/2 here. If we can just calculate the midpoint of those x-intercepts there, that's 1 plus 5/2. So this is for 9.3. And then over what? Over 2. Then we have what? When we punch all of this into our calculator, we will get 7/2 divided by 2. And then this is going to be 7/4, right? So that means that the point of inflection would have to be somewhere here in between. This would correspond to the axis of symmetry when it comes to the parabola function or the derivative. When it comes to the derivative, it actually represents the axis of symmetry. The axis of symmetry is what we refer to as the point of inflection. So that's your 7/4. Right. But then remember, we are trying to answer where is it concave up, right? Remember, dealing with concavity, this means what? Concave down. And this means what? Concave up. So we are trying to check, where do we see the shape? Where do we see a shape like this on our cubic function? On our cubic function, we can see that this will start being concave up just right after the point of inflection. Just right after the point of inflection. Remember, at the point of inflection, we say that's where the cubic graph changes concavity. So at this whole point here, from here all the way to that point of inflection, we can see that the graph is imitating the shape, which is concave down, right? But then just after the point of inflection, now it's imitating that shape, which is concave up. So that means our solution here will then have to be what? When x is greater than what? 7/4. When x is greater than 7/4, that's where we see the graph of f. So graph of f is concave up at that point. Right, so that's how you are supposed to answer those ones. So note that you couldn't answer this question unless you know the relationship of the cubic function and the parabola, right? So make sure that you always know that. And then now we come to 9.4. It says determine the value of k for which y is equals to f of x plus k will have 3 positive x-intercepts. Now, what is the meaning of this? This means when you shift the graph of k when you shift the graph of f, k units, right? So how many units would you need to shift the graph of f so that you have 3 positive intercepts, right? Note at this point, you only have 1 intercept and it is actually negative. So now you want to have 3 positive x-intercepts. You know that that can only be achieved if you want to shift the graph downwards, right? So that can only be possible if you want to shift it down. Now, you want to have 3 intercepts. Let's say you shift this. Let's say you shift this 9 units down. If you shifted 9 units down, that's 7 minus 9. Then it's going to intercept somewhere here at -2. But then if you shifted 9 units down, this point here that we are seeing will now be here, right? So this point here of A will now be 1:0. And then this point that we are seeing here, this point that we are seeing there will now be what? 5/2. And then if we shifted 9 units downward, that's -9, right? So how many intercept will we have here? That's 1 and then 2. Remember, we want 3. Let's say we shift this one here. Let's say we shift 8 units now. If we shift 8 units, this is what happens. So this point here, this is what we're going to have. So bear with me. I will show you what I'm trying to do here. I will show you what I'm cooking. So the point in here would be 5:2:0. 5/2 is 0. And then the same point here. The same point here. Let me fix it. The same point of A there would now have to be what? 1:1, right? If we shifted 8 units. Now, note that in both of these situations, how many intercept do we end up having? 2, right? So with this one, so note that this would have to be all the way like this. Right, yes. So in all of this, we only have 2 intercepts. Our mission is to have 3 intercepts. So we understand that anything that will occur in between these 2 graphs here will lead to 3 intercepts. So if I can just draw this curve following the same shape, but then within that path, what do you notice? What do we notice? See? All of these points here have how many intercepts? 1. Okay. This is going all the way like that. 2 and then 3, right? And then if in here, this is 1, and then 2, and then 3. And then also with the other one, we have what? 1, 2, and then 3. So all of the graphs that will be drawn in between here will have 3 intercepts, which is what we are actually looking for. But then how many units would you have to move this graph here so that you have that thing being possible? So it means that you would have to move your K more than 8 units. So your K would not have to be, your K would have to be more than 9 units down, but then not actually more than 8 units down, right? So K has to be greater than -9, but K has to be less than what? -8. So in between there. So in between when you shifted 9 units down and then when you shifted 8 units down. This means in between when you shifted 9 units down and 8 units down, because all of this is occurring in between where you shifted the graph 8 units down and in between where you shifted the graph 9 units down. I hope it makes sense. Right. So it's in between there. It's in between there. So whenever you draw curves in here, they will have three intercepts. So why are we not including the -9 and -8? It's because when you shift it exactly 9 units down, you only have 2 intercepts. When you shift it exactly 8 units down, you only have 2 intercepts as well. But anything that will be in between there will give you 3 units. Will give you 3 x-intercepts. Right. Okay, question 10. We have our question here. It says a cyclist rode from town P and stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented by this equation, right? So this is the equation to represent the speed in kilometers per hour. They say, note, speed is the rate of change in distance with respect to time. Then 10.1 says, calculate the maximum speed that the cyclist reached on this ride. The what? The maximum speed, right? Now, first, let's understand this. Our S in terms of T represents the distance. This is the original formula. Then our S prime T would have to represent the speed or the velocity. So, and then we have our S second derivative of T would have to represent the what? The acceleration. Now, if we are looking for the maximum speed reached, that means we have to look at where the acceleration would have to be equal to 0, meaning that the maximum speed is a constant speed. So this is a constant maximum speed. So a constant maximum speed would mean that my acceleration would have to be 0 meters per second square, meaning according to this, my second derivative would have to be 0. Right? So in order to calculate the maximum speed, I would have to find the time at which there will be an acceleration of 0 meters per second square. So what do I do? Come over to this one and say I am given this speed equation. So the equation to represent the speed, but let me derive it further so that I have the equation to represent the what? The acceleration. So that's -60 and then plus 18. But then acceleration would have to be 0 for me to reach a maximum constant speed. So that's -60 and then plus 18. Transpose this one, that's 6t, and then equal to 18, divide by 6 both sides, then t would have to be equal to what? 3 hours, right? But then I'm not done because all I'm trying to calculate is the maximum speed. So I just found the time whereby the cyclist will reach that maximum speed. So after 3 hours, the cyclist will come to a maximum speed. And at that point, it will be moving at a constant velocity, a constant speed, right? So, okay, now at this point, we are just going to say, let's take this 3 here and use it on this formula now, because we are trying to find the what? The maximum speed, right? When that acceleration is 0. So t is 3 here. That means I'm going to come there and put 3 wherever there is t. And then when I punch all of that into my calculator, I get 27 and then kilometers per hour. So that is the maximum speed that will be reached by the cyclist after some time, right? After 3 hours. Okay, then that's how you were supposed to calculate that. That's how you were supposed to calculate that. So making that equal to 0, it's a mark, and then having to find the value of t, it's a mark, and then having to find 27 kilometers per hour, it's a mark. So 3 marks like that. Okay, then calculate the distance between point P and town T, right? How do we then calculate this? Again, let's keep this here. So we still understand that ST is the distance, S prime T, first derivative is the speed, and the second derivative represents the acceleration. Now we are to calculate the distance between point P and town T. But then remember what we are being told. The cyclist rode from town P and stopped at town T, right? There are 2 points whereby the cyclist will be found to be stationary. Initially when he's starting at town P, and then finally when he has now stopped at town T, right? So that means here we are trying to calculate. So with this equation here, we can calculate where our acceleration, where our speed will be equal to 0. Remember, speed equal to 0 meters per second means that this is at rest or has stopped, right? So this means it's at rest or stopped. Now, this question is a little bit unfair for those ones who are not doing physical sciences, right? I feel like such questions shouldn't be there because now, what about the ones that are actually doing accounting? Right. So, but then a little bit of physics background actually helps you to answer these questions. Calculate the distance between town P and town T, right? So, okay, this is what we are going to do. First, we understand that if we can make our ST 0, it means that the speed is 0. And at that point, it means that the cyclist has stopped. So we're going to start by saying S prime T is equals to negative 3T squared plus 18T. Then we put 0 here. Negative 3T squared plus 18T, right? So we can take it over to the side. 3T squared minus 18T is equals to 0. Factor out 3T. It's a common factor between the two. And then we have T minus what? 6 is equals to 0. So we're going to end up with 3T is equals to 0 or T minus 6 is equals to 0. Where we would have to divide by 3 both sides here, and then T would still be equal to 0, or T would be equals to 6 hours. Now, obviously, the 0 represents that initially when he starts at town P, he would have been stationary before he starts cycling. And then 6 hours, that's when he reaches town T and stops there. So obviously, we have to continue with the T is equals to 6 hours. But remember that in order for us to have to calculate the distance, right? In order for us to calculate the distance, we would have to actually do this. So remember that the distance is represented by this formula here, right? ST distance. So how do I get this to that, right? So this is S prime T, right? And then it's negative 3T squared. Remember, this was derived up until this point. So if I say my derivative is negative 3T squared, then plus 18T, how do I get this to ST, the original formula? Now I have to understand that this becoming negative 3T squared means that initially here I only just had a negative, right? And then this is what I do. So note how I take it back. Remember, I know that it's a jump down and then subtract 1. If I bring back the 1 here, this is supposed to be negative 3. This is supposed to be negative T and then cube, right? Now I'm going to use this cube here, this 3, to divide to that negative 3, which will give me negative 1. So this is supposed to be negative T cube. And then again here, I know the same thing happened. Exponent jump down and multiply with the coefficient. So if this is 18T, I know that it actually comes from T squared. And then there has to be a certain number that multiplied with the 2 so that we can get 18. So I'm going to take this 2 here, divide it to this 18. So 18 divided by 2 will give me that the number in question has to be 9. So that's how I find the original equation. So my original equation for the distance is what? ST is equals to negative T cube plus 9T squared. But then remember that the time is 6 hours. So we want to find what is the distance that has been covered in 6 hours. So in 6 hours, we would have to say if our T is 6 here, then what is the distance that has been covered within that 6 hours? Then we put the 6 there, put it into our calculator. Then we find that it will be 108 kilometers, right? So it's 108 kilometers. That's the distance that has been covered. So that's how you are supposed to get that. But then you have to actually get it from all of this, understanding that your ST is the distance, your S prime T is the speed, and then your second derivative in terms of T is your acceleration. So, right. Pretty interesting question there. Okay, so we have question 11 on probability. That's your grade 11 probability Venn diagrams. So a certain number of learners are sitting for examination in mathematics, tourism, and geography. And then 11.1, they say, draw a Venn diagram to represent all the learners sitting for these examinations, right? So you will have your Venn diagram first, and then obviously indicate your cycles here for these three events. And then there we go. Okay. Then you're going to label the events using symbols. So that's your mathematics, tourism, and geography. Make sure that you keep to the same order so that it will be easier for the markers to mark according to the memo. Then all these learners sit for at least one of these examinations. That is to say, none of the learners are outside here, right? None of the learners are outside. All these learners that were being investigated here or in the survey actually wrote one of those exams. Then 6 learners sit for only tourism. So let's start down here. 6 learners sit for only tourism. So tourism only is 6. 3 learners sit for tourism and geography, but not mathematics. So tourism and geography, not mathematics. So that means that 3 has to only occupy the space. So without the mathematics. So this is without the mathematics. So only tourism and geography. And then we have 4 learners sit for mathematics and geography, but not tourism. So mathematics and geography and not tourism would have to be represented by this. So that's mathematics and geography and not tourism, right? So that means it's how many learners? 4 of them. So we have 4 here. And then 5 learners sit for mathematics and tourism, but not geography. So mathematics and tourism, but not geography, would have to be represented by this part here. So that's how many learners? 5 learners. Right. Then they say the total number of learners sitting for geography is 18. Right. So the total number for the ones in geography is 18. So all of this must make up 18. Okay. So let's save that for now. The total number of learners sitting for tourism is 16. Now we can deal with this because we only have one missing value. But then the reason I said let's park this one, it's because we don't have a value for here. We don't have a value for there. So let's focus on tourism now. So 16, that means this whole circuit here must add up to 16. Now we have 5 plus 6, which is 11, and then plus 3, which is 14. So that means right here we must have what? 2. So that all of this makes up 16. Now, which means we can come back to this one. So all of this must make up 18. So we have 4 plus 2, which is 6, then plus 3, which is 9. So that means in order for this to make up 18, there has to be 9. So only 9 learners set for geography only. Right, then we go to mathematics. The total number of learners who sit for mathematics is 22. So meaning all of this must make up 22. So 4 plus 2 is 6 plus 5. That's 11. Then to make up 22, that means I need to have 11 here as well, right? So, okay, all of this now is now filled up. The Venn diagram is now filled in just like that. So understand when it says but not, it means that you only consider these ones, right? But then all in all, there are 6 learners that do mathematics and geography, right? So 6 of them, irrespective of whether they only do mathematics and geography or they also have tourism. And then there's also 7 learners between mathematics and tourism, right? There is 5 learners between tourism and geography. So I need you to note the difference when it says but not, and then when it just says mathematics and geography without that exclusion of but not or only, right? So this is 11.1. Then 11.2 says calculate the probability that a learner chosen at random will sit for examinations in at least 2 of the subjects, right? At least 2 of the subjects. At least 2 of the subject means that it can be 2 or more, right? The word at least means it can be that 2 or more, right? Meaning the ones that sit for 2 are these ones, right? So how many learners exactly sit for 2 exams? There's 5 learners that sit for maths and tourism. There's 4 learners that sit for maths and geography. There's 3 learners that sit for tourism and geography, right? But then they said at least, meaning it can be those learners and also the ones that actually sit for all those 3 exams, which means we must also include those 2 learners that actually wrote all the subjects there that were mentioned, right? So that means we're going to say probability of at least 2 is what? Is 5 plus 2 plus 4 plus 3. And then all over what? Remember, probability of an event should always be the number of times that event can occur over the sample space. Now, what is the sample space? We need to find out how many learners were actually being investigated there, right? Of which from here we are not being told. So how do we then find the sample space? The sample space will be found by adding all these numbers here, 9 plus 3 plus 2 plus 4 plus 11 plus 5 plus 6, right? Now, when you add all those numbers, you are supposed to get what? 40, right? Then adding the numerators here, 5 plus 2 plus 4 plus 3, that will give us 14 and then divided by 40. And then when we simplify, that becomes 7 over 20, or can be written in decimal form as 0.35, right? And then that's basically how you are supposed to have that. Okay, nice. Then we then have 11.3. It says determine if the events sitting for examination in mathematics and sitting for examination in tourism are independent. Support your answer with the necessary calculations. Now we know of this independent events. P of event A and B, so the intersection between the 2 events would have to be equal to the product of those 2 events, right? So that means in our case, we are looking to check if our P, M, and T will be equals to probability of maths multiplied by the probability of tourism, right? Now, what is the probability of maths and tourism? How many learners are doing maths and tourism? Note this. I did not say maths and tourism only, just maths and tourism, meaning it can be the 5 plus the 2, right? Because there is no exclusion to say they must be doing maths and tourism only. It's just maths and tourism. So anyone who's doing maths and tourism, irrespective of whether they're doing geography again. So that means I will have what here? 7 over 40. Now, what is the probability of a learner doing maths, right? The probability of a learner doing maths is 22 over 40. And then the probability of a learner, so a learner just doing maths, not maths only, just doing maths. They can be doing tourism and geography. We just want a learner that does maths, right? Not maths only, maths as a whole. Then a probability of getting a learner that's doing tourism, irrespective of whether they have maths and geography, just everyone who's doing tourism. That's 16 over what? 40. Now we want to compare if the 2 sides will be equal, right? So what is 7 over 40? You can actually write it in decimal because as a fraction, you wouldn't be able to tell. So this is 0.22. And then you're going to multiply this 22 over 40 multiplied by 16 over 40. That gives us what? The 0.22 is actually for that. So this is 0.175, the 7 over 40. And then this is the 0.22, right, for this one. Now, we can see that the 2 values are not equal, right? They're not equal, so 0.175 is not equal to 0.22. This means events M and T are not independent, right? Are not independent. Are not independent. Remember, they're only independent if the 2 will be equal. So if PA and B is equals to PA times PB, we say the events are what? Independent. But if we find that they're not equal, PA and B is not equal to PA, times PB, we say they are not independent, right? So understand that. Not independent if they're not equal, independent if they are equal. And that's how you were supposed to go about answering that question there, right? So nice one. So for your Venn diagram, it was 3 marks. So for finding those values there, So this is how they actually mark. It's a mark for having to have this 2 here. It's a mark for having correctly placed the 5, 4, and 3. And then it's a mark for having correctly placed the 6, 11, and 9. Right. So if you are curious about how they actually mark that. All right. So we've came to the last question of the exam paper, which is our counting principles, question 12. They say a company generates a 4-character code using the 26 letters of the alphabet and the 10 digits from 0 to 9. They say the code is in the form, a letter, a digit, a letter, then a digit. 12.1 says determine how many different codes can be formed if letters and digits may be repeated, right? So this is what we are going to have. And then we want to form a 4-letter code, right? With those restrictions there. Okay, so they say, how many letters do we have? 26, and then digits, it's 10. But then remember, we can repeat a letter, so that means we still have a sample space of 26. We can repeat a digit, meaning we can still use the same digit, right? We still have a sample space of 10. Then this will just be 26 multiplied by 10, multiplied by 26, multiplied by 10, which all in all, it's supposed to give us what? 67,600, right? So that's your 12.1. Now, 12.2, they say determine how many different codes can be formed if the letters D, F, I, Q, U, V may not be used. So 1, 2, 3, 4, 5, 6. 6 letters have to be excluded. The code may not start with W or a Z, right? Meaning 2 letters would have to be excluded from the first position. Letters or digits may not be repeated, right? Letters or digits may not be repeated. The code ends with an odd digit, right? Okay, so again, let's indicate that. And then we are going to say still a 4-digit code. So it's still letter, digit, letter, digit. So for the letters, we have a sample space of what? Remember, we cannot start with a W or Z. So that means from the 6 letters that are already excluded, we have to also exclude the other 2. Meaning from the 26, we only have a sample space of 18 that can go in here. But then when it comes to the digit here, right? Remember, there must be 1 digit that I reserve in order to use it as the end digit, right? So it must not be repeated, meaning it affects our sample space for this one. I can use all digits here, but then I have to make sure that I reserve 1 digit, which will be an odd digit. So that means here I can only put a maximum of 9, right? I can only have a maximum of 9 to choose from, with an exclusion of 1 digit that is an odd digit. So with an exclusion of either a 1, a 3, a 5, 7, and a 9, right? So when it comes to here, this is it. So I'm going to say how many letters? Remember here I only had 18, but then I should not repeat the letter, right? So when I come back to this one, if I were to repeat a letter, that means I would have a sample space of 20. But then from the 20, remember there is 1 that I've already put in here. So that means this decreases my sample space to what? To 19. So in total, we have 26. We are excluding the 6, but then we have also used a letter here in the first one. So that means we are only left with 19, right? And then from here, remember, this is where we should put the odd number, right? How many odd numbers can we choose from? It's not 1. Remember, we are saying that in each and every case, you have to exclude 1 digit, which has to be an odd digit. But then the sample space of the odd digits that you'll be excluding is what? Is 5. Because it's either going to be a 1, a 3, a 5, a 7, or a 9, which are 5 digits that you can actually choose from, right? So that's a probability, that the probability is showing you the number of options that you have in terms of having to substitute in that particular block. So that means it's 18 multiplied by 9, multiplied by 19, multiplied by 5, which will give us what? 15,390. Right. So that's it. Then they're now saying the company wishes to increase the number of 4-character codes formed in question 12.2 by allowing the letters D, F, I, Q, U, and V to be used. So the ones that they initially excluded, they're now saying you can use those ones because now we can see that we are having a shortage of codes. So now let's allow those digits that were formerly not allowed to actually be in the mix of the sample space. So, okay, if we were to create here a code, how many digits will now be formed with this new restriction, right? Or this new permission that we've been given. Okay, so it means here our sample space would no longer be 18. It would be the 18 plus the 6 that were excluded. So, so that would mean that we have what? 24. Remember the W and Z, they did not speak anything about it, right? So that means W and Z is still excluded for the first digit here, for the first block, right? So the code must still not start with a W or Z. So that means we only have a sample space of 24, right? Now, nothing has been done to the digits. So digit will still be 9 here, and then it will still be 5. Now, let's come over to this point here. What should I then put in here? Remember, if this are being allowed, that means if I were to repeat, I would have 26, all 26 of them. Because remember, the restriction for W and Z only applies for the first block here. But here, there is no such restriction. So I would have 26. But then I have to consider that still I do not have to repeat the letters or digits. I have already used one letter here. So that means my sample space remains what? 25, right? And then, okay, now this is going to be what? The 24 multiplied by 9 multiplied by 25 multiplied by 5, which is going to give us what? 27,000, right? Now 27,000. Okay, so this is what we are going to do. They are saying we must calculate the percentage increase in the number of different codes that can now be formed, right? So to calculate the percentage increase now, this is what we need to do. We have to say the new number minus the old number divided by what? The old number. So if you still remember in grade 8, grade 9, we used to have this formula here for percentage increase. New minus old over old times 100. So the new number that of codes that would be formed is now what? 27,000. But the old number was only 15,390. And then over the what? The 15,390 multiplied by 100, right? And then when you punch all of that into your calculator, as a percentage, you will get what? 75.44% rounded off to 2 decimal places, right? And that's how you were supposed to calculate that. Awesome. Okay, so pretty interesting question right there. Pretty interesting question. That's how you could have bagged yourself the 8 marks there. So make sure that you practice this segment of your probability there, right? So this is where you should be collecting marks, your grade 11 probability and grade 12 probability. This is the topics that you use to supplement your marks throughout the exam. Right, so that's it, guys. Make sure you share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.